Ladies and gentlemen, welcome back to another Advanced Placement Calculus lesson. Okay, we got our AP exam very, very soon. Okay, remember it's on May 12th. Okay, so that's a week from tomorrow. Today, actually it's a week from today. Today is Tuesday. Right now it's Monday. I'm making Tuesday's lesson. But your AP is 1 week away, okay? What we're going to try to do this week is focus more on what I think you're going to see on the AP. You know, they've released some questions on AP Classroom that you can actually access if you want to. They're unlocked. I'm going to make dittos of those questions anyway. We're going to work on them Thursday and Friday. I think they're kind of giving us a wink, as far as what might be on the exam. So I figure we'll cover that toward the end of the week. Monday, we'll do a little bit of fine tuning. Okay, anything, extra I think we need to actually practice. And I'll give you guys some stuff to practice over the weekend. You'll see on my website, yesterday, hopefully toward the end of the day, I posted a video as far as uploading, your answers on the AP exam. As of this moment right now, I don't know if I'm going to post a video of myself or if it's going to be of somebody else. There's actually somebody on the AP, listserv who has a really good video as far as downloading, and uploading your stuff is concerned. So I might just go with that video. Don't think that I'm, cheapening out or anything. You want to plan for this AP exam, okay? You want a nice little spot in your house that's going to be quiet, okay? You want to have that checklist printed up. I hope you took a look at that testing guide. It seems like a lot of pages, but it's not as bad as you might think. And that demo should be accessible as well. So really kind of got like two options. You could take the AP with your phone or a tablet. The annoying thing about that is actually having to zoom in on the question and being able to see the entire question. Maybe it's not too terrible. Maybe you're used to it anyway because you stare at your phone all day. The nice thing about that is you can upload an image, okay, right from your phone. If you take a picture of your work, make sure on the pages you take a picture of that you have, I think it's your AP ID number and something else written on the page. It says so in the testing guide. I'll take another look. We'll talk about it, this week. I'll kind of, throw that into each video. We'll speak about that stuff a little bit. Make sure you're set up and ready to go. Like I said, a tablet or a smartphone, you could take a picture. Should be able to upload it, okay? Check the demo out. Try it for yourself. Don't make the day of the AP the first time you try it. Or even Sunday or Monday, the first day you try it, the day before the AP. Let's see if there's an issue now that can actually be fixed. The best way to do it would probably be, on a laptop or a Chromebook. Access the AP exam that way. The problem with that is then after you write your work down, take a picture of it, you got to email that to yourself, okay? And then download it from the email and then upload it, onto your laptop or your Chromebook. Practice those things, okay? If you're tech savvy, that's probably the best way to actually do it. Try it out. And I don't want you stressed on the day of the AP as far as uploading stuff. And you want to be good at it, okay? Who knows if they're going to have issues with a bunch of different kids, trying to upload stuff at the same time. There's going to be any issues with that. If there is a problem uploading, and you can't get your answers in, they'll automatically send you a ticket to take the makeup exam, which is sometime in the beginning of June. You want to try to avoid that if you can. You want to try to take it as soon as possible. So make sure you plan these things, okay? Also, I heard that PDF files, I don't know if some of you guys have been taking a picture, converting that to a PDF and sending that to me. They look great, but apparently there's an issue with that on the AP exam, so they just want image files, not PDFs. So if you're a PDF person, get used to taking a picture with your phone and uploading that, okay, a JPEG, and there's a couple other forms that they'll accept. Also, when you take these pictures, don't take some sideways picture with your phone. Get right above your actual work. Make sure you can see, and they're able to zoom in and see your work. Make these people's lives easier. All right, so that was 3.5 minutes of me talking about, things. I hope you're watching these videos here. Let's do some more free response practice. Okay, we're going to have an integrate the rate problem going with a calculator. I don't know if they're going to have integrate the rate on your AP. There's confusion among AP teachers whether it's on there or whether it's not, because you could make an argument that it's on there, that the, piece of the curriculum that was left in. You can make an argument that it's part of the curriculum that was taken out. So we will do at least, one or two more, okay? And then as we get toward the end of the week, we'll focus more on what, I feel will more likely be on there, but we'll do an integrate the rate. Then we'll do an XVA, which also XVA, a lot of people aren't thinking it's on there because they said that they're not going to deal with position, velocity, acceleration when integrals are involved. But there are some XVA questions like this one right here that doesn't involve any integration, unless you want to talk about the last part, okay? But most of it doesn't involve integration. So there could be something like that, okay? I'm not 100% at an XVA being on there or an integrate the rate, but it's Tuesday. Let's do a couple of those problems. Then we'll focus more, as far as Thursday and Friday, what I really think is going to be on there. And then Wednesday, of course, you know, some things in between, okay? A couple other types of problems I want to try. So look, there's a 2016 problem right here, graphing calculator required. I don't think you're going to have graphing calculator problems on your AP. They said you could have the calculator, but you won't really necessarily need to use it. But they could change this problem in a way to make it non-graphing calculator. We'll talk about that soon enough. We got water is pumped into a tank at a rate modeled by this guy right here. So the rate at which water is pumped into the tank is this guy here. That's an entrance rate, right? A rate in. Remember, if you integrate the rate at which water is pumped into the tank, you'll find out, very good, how much water is pumped into the tank. They tell you that this is measured in liters per hour, T is measured in hours. Then they tell you water is removed from the tank at a rate modeled by R of T liters per hour. So if you integrate the rate at which the water is removed, you'll find out how much water is removed. They don't give you a function for that. They don't even give you a graph for that. They actually give you this table right here. They tell you that R is differentiable and decreasing from 0 to 8, and they give you selected values of R of T. Then they tell you time T equals 0. There are 50,000 gallons of water in the tank. Liters, pardon me, gallons of water's in the tank. I think we know of water's in the tank. I think we know what that represents. That's our initial condition. Be careful whenever they give you a function represented tably. This function right here, they just gave it to you, and then you need to figure out whether or not it's differentiable or decreasing, whatever it's doing. You have a calculator anyway. But R of T, they got to tell you some stuff. They don't tell you much about a function when it's represented numerically or tably, if you want to say it that way. But we do know it's differentiable. That means it's also continuous. So hopefully nothing really crazy going on. And then they also tell you it's decreasing. Let's jump into part A. You know, this kind of combines integrate the rate and tables at the same time. Okay, you know, here they want you to estimate R prime of 2, show the work that leads to your answer. Remember, if you want to estimate instantaneous rate of change, you use average rate of change, okay? And you should try to go a little bit to the left and a little bit to the right. You'll see that 2 is right here. Okay, so we're going to get the average rate of change from 1 to 3. So that's going to be R of 3 minus R of 1 over 3 minus 1. This normally you see in a tables type of problem. They could easily give that to you on your AP, okay? This is always there when they give you a table problem. You know, two problems, I don't think both are going to be abstract. I feel like one's going to be applied and the other's going to be abstract. Once again, we're not sure, so we do the best we can. Here you can actually go right to the answer, you know. Well, can you go right to the answer? I don't know. Maybe that's a little dangerous. You know, technically, they need to know, you know, how to, you know, evaluate a function. Even though from here it's a table, it's really easy. So we know R of 3 is 950 minus R of 1, which we know is 1190. And let's divide that by 2. You could even leave it this way if you want. There's nothing wrong with that. You have a calculator, so very easy. 1190, was that the year Harrington was born? Okay, divided by 2. So that gives us negative 120. Really, on your AP, you might want to leave it right here anyway. Okay, one little thing you hit wrong in the calculator, they're going to take a point away from you. Don't simplify on your AP exam. Unless you need to use that answer somewhere else in the problem, then it might be useful to simplify it. Units of measure, so important. You know, looking at your take-home assignment, some people are flubbing this up. I know we're using R, and I know R is in liters per hour, but this is not in liters per hour. This is the rate at which R is changing with respect to hours. It's really liters per hour divided by hours, and that's liters per hour squared. All right, too many people on the liters per hour. It's lit per hour squared. Too many people on your take-home, one of the assignments I sent out. I think it was supposed to be in meters per year when you did something like this. Too many people just put meters, okay? Remember what you're getting. You're getting the rate of change of R. R is in liters per hour. This is in liters per hour. That's why it's liters per hour squared. Don't make silly mistakes like that on the advanced placement exam with units. You're better than that, okay? So too many people made that type of mistake on take-home assignment number 3, I think it was. Take-home assignment number 4, going to be assigned, going to be due today, I think, okay? And I think I'm going to assign another take-home assignment today. We'll see how things go. Probably due Friday. B, this is a great problem. Use a left Riemann sum. So that's kind of cool. With 4 subintervals indicated by the data in the table to estimate the total amount of water removed from the tank during the 8 hours, and then they want to know if it's an overestimate or an underestimate of the actual total amount of water. So look, if you want to know the amount of water that was actually removed, you integrate the rate at which the water is removed, okay? And remember, R of T is the function that represents the rate at which the water is removed. And just be careful with the bounds here. They say over the 8 hours, so the bounds are going to be from 0 to 8. And this is kind of cool. You know, we can't get exactly what this answer is equal to, okay? Because, you know, we don't have a function for R of T or a graph for R of T. We just have selected values. So we have to approximate this. and we're going to approximate it using a left Riemann sum. It's definitely going to be a Riemann sum approximation on your AP, okay? I would stake my heart on it right there. We've done several trapezoidal sums, which technically aren't Riemann sums, but still kind of falls in the same category. We've done several trapezoidal sums. They've all been using the subintervals indicated by the data in the table. I'll make sure we do another one where the subintervals are equal. So you could actually, do the expansion for the trapezoidal rule. Really, you could still, if the subintervals are equal, you could still use the technique we used last time and just calculate the areas of the trapezoid separately. But that one is a very popular problem, so that's why I gave you a bunch like that. They also have you do Riemann sums. Sometimes Riemann sums, it's subintervals of equal length. I'll make sure I get something like that to you a little bit later on this week. Those are really easy. Then you can do the expansions. But sometimes it's a Riemann sum with the subintervals indicated by the data in the table, okay? And it's over the first 8 hours. So what are my subintervals here? Okay, 0 to 1, 1 to 3, 3 to 6, and 6 to 8. So here you actually have to calculate not the area of a trapezoid separately, the area of all the rectangles separately. It's a lot easier because the area of a rectangle is base times height. Think about that first rectangle. It starts at 0 and it ends at 1, right? Okay, so we know that it's base times height. So we know the base is just going to be delta x here. It's just going to be 1. All right, so there's my base. And my height, remember, since it's a left Riemann sum, I plug the leftmost x value, or t value in this case, in to actually get the height, okay? And that would be 0 right here. So that's r of 0. So that's the first rectangle. It's a lot easier than trapezoids. Okay, the second rectangle, it goes from 1 to 3. So the base is 2. And then since it's a left Riemann sum, we plug in the 1, the leftmost one. So we put r of 1. Make sure you show them that you're doing that, okay, that you're plugging into the function. Plus, and then we know the next one goes from 3 to 6, so it has a base of 3, and then r of 3. And then finally, the last one goes from 6 to 8, has a base of 2, and since it starts at 6, we're going to have r of 6 to actually determine that height. Then plug in, okay, 1 times r of 0, we know is 1340. So the year Mr. Harrington graduated from college. Plus 2 times r of 1, which is 1190. Remember, that was the year Harrington was born. Plus 3 times r of 3, which was 950. Number of dates I had this weekend. Beautiful weekend, by the way. Hope you're studying outside. And then 2 times r of, what was this, r of 6 over here, which we know is 740, which is Mr. Pushy's SAT score. Anyway, so this right here, that's the answer, okay? You could actually calculate what it's equal to because you do have the calculator, but it's not necessary. Once again, I box this thing in. Okay, and it actually comes out to 8,050. And then they also said, estimate the total number of water removed from the tank. They didn't say units, but it's implied that you want units there. Remember, if you integrate liters per hour with respect to hours, you get back liters. Okay, really, this is just the amount of water that was removed from the tank. That's going to be in liters. That's not going to be in liters per hour. That would be the rate of change of the water in the tank. So be careful with something like that. Be careful with your units. It could be really a difference between a 3 and a 4 or a 4 and a 5 on the AP exam. Then they want to know if it's an overestimate or an underestimate. Remember, Riemann sums, to know if they're overestimates or underestimates, you got to think about increasing and decreasing. Just like trapezoidal sums, to know if they're underestimates or overestimates, you got to think about concave up or concave down. So this thing right here, they tell you that r is always decreasing, right? They tell you it's a decreasing function. Just imagine you got any decreasing function. Maybe it looks something like that. Set up a few rectangles. Hey, I know there's supposed to be 4 here, so if you want to draw those 3 lines in to get 4 rectangles, be my guest. Some people are like, wait, you didn't plot the points, right? Don't bother with that, okay? Just think about it. If it's a left Riemann sum, I use the leftmost x value to determine the height. Here, leftmost x value to determine the height. This one didn't really come out that great. It should be up here, the leftmost x value. My apologies. Kind of hard to see because it's a small rectangle, but this one should be more obvious. Plug in the left. That's my height. Draw a horizontal line, bring it down. You can see it's an overestimate. Just like over here, plug in the left. There's my height, horizontal line. Here, plug in the left. There's my height. So you can see it's an overestimate. So we know this is an overestimate. And that's because r of t is decreasing. decreasing. Okay, so really not too terrible. You should be able to handle A and B here. I really do think that, if you've actually been putting in your work, I hope you have. Okay, you could do so great on this AP. There are so many people that take this AP. They have no idea what they're doing. Now this is a shortened AP. It's like an emergency year. I'm telling you, you guys got a great chance. Also, remember, they're planning on putting some parts on each question that they don't even think you're going to be able to get to, that they think are either too difficult or too time consuming. Don't feel bad about skipping those parts. Make sure you focus on the parts you could actually do, get points for that. Then go to the parts you can't do. See if you could earn a couple points, okay? Do the best job that you can. They also might have a big, short answer problem. The first problem is going to be, 25 minutes, not 15 minutes. Maybe it's 8 to 12 short answer questions, kind of like multiple choice. We'll see, okay? We practiced that as well. Part C, speaking of C, use your answer from part B to estimate the total amount of water in the tank to the nearest liter at the end of 8 hours, okay? So at the end of 8 hours, that's when T is equal to 8. Okay, so T equals 8 hours right there. It says use your answer for part B. So if you couldn't figure out what part B was, make up a fake answer to use it for part C. Remember, part B tells you the amount of water that was removed from the tank. Here we actually want to know how much water is in the tank. And just knowing how much removed is not enough. Don't forget, you got to remember how much was pumped in there, okay? Because water is being pumped in at the same time. And even if you know how much water was removed or pumped in, both of those things are meaningless unless you know how much. Very good. Water was there to begin with, and we know there was 50,000 liters of water. Okay, and that right there was at T equals 0. So now we want to know, well, how much water was pumped in from T equals 0 up to T equals, they want to know 8 here. And that means you integrate the rate at which the water is being pumped in minus the amount of water that's being pumped out. I'm just going to say 8,050. But if you want, instead of writing that, you could write this whole thing down. It's kind of ridiculous, but make sure you put parentheses around it. You're subtracting it. You could also do the integral from 0 to 8 of R of T with respect to T. Technically, though, it's not really exactly what we got here because we approximated an integral. We didn't get the obvious integral, but you kind of got the approximation here. You're probably going to be okay, all right? So even if you want, you could take a little arrow and be like, that's really this value right here. These are the types of things, if you want to type out your answer on the AP, good luck, man, okay? We need to be able to write things down in arrow. That's why you got to get used to taking pictures of this stuff and uploading it. So make sure you play around with that demo. Anyway, they said to find an estimate. Okay, so here we actually want to get an answer. All right, so I got, maybe in Y1, finally I get to use this entrance rate here, which we know is 2,000. E to the, and then a little alpha y equals, okay, up top, we got a negative t squared, so a negative x squared. Downstairs, we got that 20. Okay, so now go to my quit screen. Let's take my 50,000 right there and add to that little math niner. Integral from 0 up to 8 of alpha 20 y1 with respect to x. And then subtract from that the 8,050. So this is the type of situation where maybe it's a good idea to get what this answer is, because then it makes it a lot easier to do this part right here. Besides, you have a calculator anyway, so it shouldn't be too terrible to put that in right there. So what do they say here? To the nearest liter. Okay, so 49,786 liters. Okay, that's what I get right there. Okay, so let's see if you can see that right there. It's not terrible. We've seen stuff like Part C before. This Riemann Sum thing, if there is integrate the rate on your AP exam, they're probably going to do it this way. They're probably not going to do it the calculator way, okay, with something like this. Okay, so expect to see that maybe rolled in to integrate the rate. Also, you could do that for fundamental theorem. If you got to set up like f of 0 plus the integral from 0 to 3 of f prime of x, you might actually have to get the integral from 0 to 3 of f prime of x using a Riemann sum. So things to be on the lookout for. Part D, this is where everything completely erodes. Okay, so this is what I'm talking about in your AP. Like A, B, and C, they're all doable here, and you should feel okay about them. Then Part D, the first time I read it, I was like, I can't figure out how to do this. Usually I look at a problem right away and know how to do it, but sometimes I got to think about it. If I took the AP exam, because of the time constraint, and remember, you want to time yourself to about 15 minutes on these problems when you try the homework. I know one of them is going to be 25 minutes, but it's kind of hard to predict what that type of problem is going to be like. I'll try a little bit later in the week. But, because of the time constraint, it's possible I wouldn't have been able to figure this out on the AP exam in the time I had. But it's not as bad as you might think, okay? If you follow through with some things we talked about. From 0 to 8, they want to know, is there a time t when the rate at which the water is pumped into the tank is the same as the rate at which the water is removed from the tank? Then they want you to explain why or why not? Okay, so is there a time t where the rate at which the water is pumped into the tank, W of t, is equal to the rate at which the water is removed from the tank? That's R of t. You know, in this right here, people are like, yeah, I don't know. You know, what am I supposed to do? I'm supposed to figure out if there's any times where W of t is equal to these values here. But that's not good enough, right? Because there's so many other values in between. And this kind of leads into something we talked about when we did integrate the rate. You know, when the rate at which the water, when the entrance rate is equal to the exit rate, you know, a lot of times the way we figured that out is they wanted to know, like, when the water level, like in a tank or something, was at a maximum or a minimum or something like that. And that means you needed to consider the true rate of change and set it equal to 0, right? You know, find out when a rate of change is equal to 0 to get a critical point. You know, there are other types of problems where they want to know if, you know, the water level is like increasing or decreasing. We spoke about that. And here that would mean that the rate of change of the water level, you know, the rate at which water is entering would be greater than the rate at which water is exiting. But if the water level is decreasing, that would mean the rate at which the water is exiting is greater than the rate at which the water is entering. And we did those problems. We actually compared the two and saw which one was bigger. But then I told you at the same time, you could actually just subtract the two. Remember, to get the rate of change of water in the tank, you subtract exit rate from entrance rate, okay? And then we were able to actually figure out, we plugged in values, we could figure out if this was positive or negative. Then we know if the water level is increasing or if the water level is decreasing. That's different than this problem right here, but you could use this information to segue into this information, okay? So this actually represents the rate of change of water in the tank, okay? And they want to know if there's a time from t equals 0 to t equals 8 at which W of t equals R of t. So that really means, is there a time from t equals 0 to t equals 8 at which W of t minus R of t is equal to 0, okay? And you can actually do W of 0 minus R of 0. Okay, we get a value for that. We got our calculator over here, okay? So remember, you know, the alpha trace. Here's W of 0 minus R of 0, which is equal to 1340. You actually get 660. Why are we doing that? We'll figure this out in a second. Then you can actually go up to 8 and do W of 8 minus R of 8. Why are we using 0 and 8? Because that's the interval. We want to know from 0 to 8. Is there a time when the entrance rate equals the exit rate? And now we could just do this over here. All right, so that's W of 8 right there, minus R of 8, which is what, just 700. Okay, and I get, oops, I don't want to graph it. Well, now we have to sit here and wait for this. These are the things, try not to make this mistake on the AP, especially with these newer calculators. It takes so much longer for them to go through this. Sorry about that right there. Let's just hit enter, and I get negative 618. You could say 0.476, whatever. And the interesting thing is this. This is a new function, W of t minus R of t. And remember, W is just this nice little exponential function right here. He's differentiable, okay? Just like they told you R was differentiable. So that means that they're both differentiable. That means they're continuous. That means if you subtract them, they're continuous, okay? So we're going to say since W of t and R of t are differentiable, that means they are continuous. That means they are continuous. They are continuous. Okay, and if two functions are continuous, or if a function is continuous, you know, we've created a new function, okay? So if Wt and Rt are differentiable, that means they are continuous. So W of t minus R of t is continuous. You know, why does that matter? Well, we want to, it's supposed to say continuous, we want to force, you know, this new function to have a y value of 0. And remember, if a function's continuous, you have to take on all y values between one endpoint and another endpoint, between one y value and another y value. That's the IVT. And you might notice here that W of t minus R of t has to go from 660 to negative 618.476 when t goes from 0 to 8. So if you want to get from a y value of positive 660 to a y value of negative 618, you must hit a y value in between. We're going to say by the IVT, and that works the extreme value theorem because this function is continuous. R W of t minus R of t. There must exist some t value at which W of t minus R of t is equal to 0. And that's the mean value theorem. It's got to take on all y values in between these two y values. That's really rough, okay? If you're like, right now you're just throwing things in the air, like, really, how am I supposed to? Don't worry about that. I wouldn't really, okay? You know, I'd focus on A, B, and C here. There's going to be stuff on the AP. Even you high-end fives out there, and I know you exist, even you might get tripped up on this. Maybe you've had more time to be able to do it, but with, you know, a time constraint might be an issue for you. Or maybe you look at it and just know the answer right away, okay? Some of you guys, your intelligence astounds me. Look, but really, you know, don't worry about this, okay? Even if you want to be a 5, try not to worry about something like this. If you do A, B, and C, you're good to go. You know, the next problem is not actually from a past AP exam. It's from, I think, a practice AP that was handed out years ago. And this is going to be another problem where, you know, at first, Part A should be good, but after that, things are going to start to break down a little bit, okay? And I don't want you to freak out about that. I want you to get used to the fact that there are going to be some parts on problems that you can't handle. This also involves some trig, which is what mainly bothers people. I doubt it'll show up this year. It usually doesn't show up most years, okay? But every now and then this shows up, and if you don't have your basic trig on lock, you're not going to be able to get points that you should actually be able to get. Would they do that to you this year? I don't think so, but we're going to prepare just in case. We got 2 particles. 2 particles is getting out of hand. Now there are 2 of them. Does anybody get that little Star Wars meme on, you know, Star Wars Day? 2 particles move along the x-axis. I'm saying Star Wars Day. I think I started this whole video by saying Happy Star Wars Day. But really, that was yesterday, right? You know, because Monday, I'm making this video on Monday, but this is really the ditto, you know, the video for Tuesday. I don't know what I'm doing. You know, for me, every day is Star Wars Day anyway, so it doesn't matter. 2 particles move along the x-axis, horizontal line motion. They tell you from 0 to 6, the position of particle P is given by this trig equation, actually giving you position. It's very strange. They usually give you like velocity or acceleration, but this year they could give you position. Then they tell you the position of particle R is polynomial over here, which is kind of nice. And from 0 to 6, they want to know the times when R is moving to the right. And you know particle is moving right when its velocity is positive, okay? You know, the problem is that this is particle R right here. So when you take his derivative, obviously it's R prime of t. But really, that's the velocity. But if you just want to put v of t, I'd say v sub r of t, because there's going to be another velocity when we take the derivative of this guy right here. So this does get a little bit annoying right here. V sub r of t, we know is what? 3t squared minus 12t plus 9. And this one kind of works out nicely, okay? Because this is not like, look, you don't have to calculate it here. So it's not like you could graph velocity and check where it's above and below and draw the V line that way. You know, that's where I draw the line, the velocity line. But I got to do it the old-fashioned way because I have velocity algebraically. I got to set it equal to 0 first. You know, you might on your AP exam have to factor something with a 3 in front of the squared term or a 2. Don't be afraid. Here you don't, though, because you could just, you know, factor it out. So maybe they're nice with something like that. Let's factor this right here. It's very explosive. TNT, dynamite. Both signs are going to be subtraction, 3 and 1. All right, so easy factoring right there. So t equals 3 and t equals 1. And remember, this is where I draw the line. Which line? Well, I want to draw the V sub R line, okay? Tis it bounded? Yeah, from 0 to 6. And we're going to put all critical t values on the V line. You know, this is the old school way to do this. It's been a little while since we saw something like this. We spoke about this even last year and this year as well. So it shouldn't be too terrible. Plug in values like a 1/2 here. I'll plug in here. 1/2 minus 3 is negative. 1/2 minus 1 is negative. Negative times a negative is a positive. Plug in a 2. We get a negative times a positive. That's a negative. Plug in a 4. Positive times a positive is a positive. Okay, so easy to answer part A right here. Everybody has to get this right. When is the particle moving to the right? Okay, so moving right on. You know, be careful here. A lot of people are going to say, obviously, 0 to 1, and then we know it's 3 to 6. But you got to worry about including or not, okay? And you can't include the 1 or the 3, because those are places where V sub R is equal to 0, right? The velocity is actually equal to 0, the 1 and the 3. But the 0 and the 6, you must include, okay? Because the particle is not stopped at 0 and 6, okay? So you always have to include those endpoints. We spoke about that. 6 isn't when the particle stops. It's when you stop watching the particle. He's moving right. You look away. He's still going to be moving right, okay, even to the right of 6 right here. So also don't forget to justify. How do we know this? Well, because we know the velocity, so V sub R, is greater than 0. It's positive. So make sure you actually justify it as well. So hopefully not the worst thing in the world. You know, you could say V sub R, little r if you want to, but I think my answers, I'm looking at them right now, they have a little r. I'll use big R because it's a big particle. No big deal. okay? Because it's the, the position is represented by r, particle r. Anyway, moving on to B, and here's where the frump commences, okay? Now you want to know when the particles travel in two opposite directions. And at first it's not so bad because you're like, I know the directions for the particle r right now. Let's get directions for particle p. Well, that means you got to take the derivative of p, right? Because that's position right there. And this is going to be another velocity, but I'll say v sub p of t. Pull the 2 to the side, just a constant connected by multiplication, times, you got to know how to take the derivative, cosine pi over 4t. In a world of derivatives, cosine is the bad guy. Okay, so negative sign, rewrite the inside, chain, roo-hoo, and then multiply by the derivative of the inside. Derivative pi over 4t is just pi over 4. Don't be afraid. Probably want to simplify it a little bit. So 2 times pi over 4. Divide by 2 top and bottom. So we get negative pi over 2 sine of pi over 4t. All right, so that right there is really my velocity function. We want to set it equal to 0. And if you do set it equal to 0, you could divide by negative pi over 2 on both sides to just get 0 equals sine pi over 4t. So all I did was set this equal to 0, divided by negative pi over 2 on both sides. 0 divided by negative pi over 2 is still going to be 0. And this is where you have an issue. You're like, wait, how the heck am I supposed to solve this? It was easy to solve 0 equals, the velocity before. How do I solve it here? Well, you got to think about it, okay? They're talking about the sine function, right? Sine of something. And if you graph the sine function, we all know what it looks like, okay? Here I'll actually go from 0 to 2 pi. Now, why would you go from 0 to 2 pi? They're going from 0 to 6, okay? Believe it or not, 6 is kind of an approximation of 2 pi, 2 times 3.14, yada, yada, yada. So they do this sometimes, okay? So really, you can kind of almost even ignore that. I know it's not so easy here. And we know this goes, this is a little pi right here. Here's my 0. Now, why is this important? Because you can see on this interval, there's 3 times when sine is equal to 0, when it's sine of 0, or the sine of pi, or the sine of 2 pi. So really, you want to take this argument, find out when it's 0, because if it's 0, then you have the sine of 0, which is 0. Find out when it's pi, because if it's pi, you have the sine of pi, which is 0. And then find out, when it's 2 pi, because if you have the sine of 2 pi, that's 0. So believe it or not, you just want to figure out where this argument, this pi over 4t, by the way, right now, if you totally shut off, I understand, but you could do this, okay? You don't need to shut off. It's just something we haven't seen in a while, and it rarely shows up, but if it does, you're going to be prepared. Pi over 4t, really easy to solve, right? T has to equal 0. Okay, so that's actually one place where this velocity is equal to 0, when t is equal to 0. So I have one of the values there. Now if you check that pi over 4t, and now you say, what, I want it to be equal to pi, because that's another place where the sine function is equal to 0. Divide by pi over 4 on both sides, same thing as multiplying by 4 over pi. We actually get t equals 4. That's another place, okay? It's another critical t value. Then you're supposed to take the pi over 4t and set it equal to 2 pi, right? It's another place where it actually hits right there. And now we get t is equal to divide by pi over 4 on both sides, really multiplying by 4 over pi. The pi's are going to cancel. 2 times 4 is 8, but this is outside our domain. We only wanted to go from 0 to 6. See, that's why there are many different times when sine is going to be equal to 0, not just when the argument is equal to one of these 3 things, over here at negative pi, over here, there's going to be another one as well, at 2 pi plus pi over 2, right? No, plus pi, okay? Regardless, those values are going to be outside the domain. It's only the 0 and 4 that you're looking for, so it's not as hard as you might think. Then you got to draw that v sub p line. 'Tis bounded from 0 to 6, but it's only the 4 that's on there. Then people freak out. They're like, well, great, now I got to plug back into the v of p. How the heck am I supposed to know if this disgusting thing is positive or negative? It's actually easy. Plug in a 1 right here. Then it's negative pi over 2 times the sine of pi over 4 times 1. So it's just negative pi over 2 times the sine of pi over 4. The sine of pi over 4, you should remember, is radical 2 over 2. But how about this? We know this is pi over 2 right here. So pi over 4 is really in here. Look at the sine curve from 0 at pi over 4. It has a positive y value. So that's how I know the sine of pi over 4 is positive. Just be careful. You're multiplying it by this negative right here. Negative times a positive is a negative. If you put a 5 in here, you get 5/4 pi, right? Pi over 4 times 5. 5/4 pi, Well, that's a number bigger than 1 times pi. That's a little bit to the right of pi over here. It's bigger than pi, right? 5/4 pi, because 5/4 is bigger than 1. That's going to be negative, the sine of 5/4 pi. I don't care what it's equal to. You could use a reference angle if you want to. I know for my solutions I used a reference angle, but you could if you really want to. But it's not necessary. You just need to know if it's positive or negative. It's negative. Just be careful. A negative times a negative is a positive. So that's how you create that line, which is difficult to do. I get it. And now you got to figure out, when the particles are traveling in opposite directions, that's when V sub r and V sub p have opposite signs, right? So when you compare these two lines right here, it's not as bad as you might think. This 1 and this 3 are actually on this line right there. And this 4 is on this line as well right here. So you want to know when they're moving in opposite directions. So from 0 to 1, V sub r is positive, V sub p is negative. So that's opposite directions right there. So 0 to 1. Also, this is moving at t equals 0, but this guy stopped at t equals 0, so they can't be moving in opposite directions there, so I won't include. This guy stopped at t equals 1, so I can't include the 1 right there. Then you can see from 1 to 3, they're moving in the same direction, right? The velocity is negative from both. From 3 to 4, we can see this velocity is positive, this velocity is negative, so 3 to 4 is another one. Don't include the 3, don't include the 4. This guy stopped at 4, this guy stopped at 3, so we're not actually going to include them. Okay, and then from 4 to 6, you can see they're moving in the same direction. Make sure you justify, okay, and that's because, V sub r and V sub p have opposite signs. Have opposite signs. So you can see, you say if you want, V sub r is positive and V sub p is negative, or V sub r is negative and V sub p is positive. Same exact type of thing right there. So look, it's nasty, really just because of this, but who knows, maybe it shows up in your AP exam and you're able to do something like this and get some points. I don't know if it will, but this is kind of the miscellaneous stuff. Let's talk about this stuff that might show up, might not show up. Let's get you prepared for it. Then toward the end of the week, we'll kind of focus in a little bit more. Part C. Find the acceleration of particle p at t equals 3. Is particle p speeding up, slowing down, or neither at t equals 3? So now acceleration at t equals 3 for, the particle p, that's the derivative, the second derivative position, right? So it's going to be r double prime, it's going to be p double prime of t, which is really just the derivative of v sub p, right? So v sub p prime of t, which really we'll say is equal to a sub p of t. And that's just the acceleration of particle p, okay? And it's just the derivative of this guy right here. Pull that negative pi over 2 to the side. Take the derivative of sine pi over 4t. Remember, the derivative sine is cosine. Rewrite the pi over 4t. And don't forget to multiply by the derivative of the inside. Definitely a filthy problem here. This simplifies down to be what? Negative pi times pi is negative pi squared. Over 2 times 4 is 8 cosine of pi over 4t. So you get points for that right there. Now they actually want you to find the acceleration at t equals 3. So it's easy to plug a 3 in here. A sub p evaluated at 3. That's going to be negative pi squared over 8 cosine of pi over 4. Pi over 4. See right here, can they read what I just wrote? I don't know. Get one of these if you're not using a pencil for during the AP exam so you can erase easily. Make sure everything is written legibly. Some of you guys have horrible handwriting. Some people write like a robot, like Hannah Kleinman writes like a robot, seriously. And Kerry Radigan, same thing. Fantastic handwriting. Some people, the handwriting isn't so good. Tristan Morlock. Anyway, so over here, Sam Grark, my God, your handwriting. Dictator Grark, I don't mind insulting you over a video. Please don't show up in my house. Anyway, so here's that acceleration right there. I put a T, and I shouldn't put a T. I should have put a 3. Okay, I'm sitting here insulting people, writing the wrong thing down. Good thing I'm not taking the AP exam. Okay, so this right here, you could even say 3 pi over 4. It's the same exact thing. But there's my acceleration. Okay, at t equals 3. By the way, they don't give us units, so we don't give them units back. But then they want to know if the particle's speeding up, slowing down, or neither at t equals 3. So remember, you need to just consider whether acceleration is positive or negative and whether velocity is positive or negative. Believe it or not, v sub p of 3, we already know right here that it's negative, right? Because of our lines, we know that's less than 0. This guy right here, you want to know if it's greater than 0 or less than 0. Cosine of 3 pi over 4, our cosine curve. Let's not forget about my famous impersonation. Okay, the cosine curve right here. Here's pi. Here's pi over 2. Pi over 4 times 3, that's 3/4 pi. 3/4 pi is going to be in between 1/2 pi and 1 pi. So it's actually going to be negative right here. So this value is negative, but you're multiplying it by a negative. A negative times a negative is a positive, okay? And thus we know if acceleration is positive and velocity is negative, we know that the particle is actually slowing down, okay? So particle P is slowing down because, okay, we know that V sub P of 3 is less than 0. And A sub P of 3 is greater than 0. Okay, so that'll actually do it right there. So pretty filthy. You know, part A is easy. Part B, it's not that it's horrible, but this gets rough. And then you could do the first part of part C. You could do acceleration. You could plug in, but it might be difficult to figure out positive or negative, and you might not have this value from B over here. I get that. D, I wouldn't freak out about so much because it involves something that you don't have to do on your AP, but it involves something else that could be on your AP that I want to talk about real quick because it's shown up before. Right, but do not evaluate. Love it. An expression for the average distance between the two particles on the interval 1 to 3. So the reason you don't need to worry about this specific problem is that average value is not going to be on your AP. But sometimes they talk about the distance between two particles, okay? And if you want the distance between two things, you want to subtract their positions, okay? You know, and that might bother people. Like maybe a particle, you know, one particle's at position 7 on the, coordinate line, you know, so here's 7 over here. Another particle is at position 4. We know the distance between them is going to be 3, okay? Because we do that by doing 7 minus 4. So the distance between, that's going to be 7 minus 4, which is equal to 3. Believe it or not, you could do the distance between by doing 4 minus 7. That bothers people because they're like, well, 4 minus 7 is negative 3, and negative 3 can't be a distance. Well, just take the absolute value of it, okay? And that'll actually give us our positive 3 right there. So believe it or not, if you want the distance between any two, positions, subtract the positions, put an absolute value around it. Because sometimes, you know, the position of one particle is going to be greater than the position of the other particle, but sometimes the position of that first particle is going to be less than the position of the other particle. It's going to change from time t to time t. So if you actually want to know the distance, you know, distance between particle R and particle P, that means you're just going to subtract the two distances, the two positions, and put an absolute value. So absolute value P of t minus R of t. Those are the two positions, right? You could put absolute value of R of t minus P of t. It won't make a difference, okay? They're both the same thing. So you could say, or you could say if you want absolute value R of t minus P of t, the absolute value of that quantity. That represents the same thing. Now, look, you got to take the average value of that because the y values of, you know, the distance function right here represent the distance between the two particles. So that's why the average value is going to be 1 over, we're going from 1 to 3, right? So 1 over b minus a, 1 over 3 minus 1, integral from 1 to 3 of whatever the heck you want the average value of. We want the average value of the distance between these two particles. Okay, and here's the distance between these two particles. Or you could use the second one. It won't make a difference. So here's the answer. The average value part you're not responsible for, but there's a problem. I don't know if it's going to show up on your homework tonight. If not, we'll probably get to it later in the week. But they actually want to know the rate at which the distance between two particles is changing. So it's really a related rate problem. And you got to take the derivative of this function right here, okay, the subtraction of the two positions. You know, these are things we'll talk about, but it's something that's, you know, it's really commonsensical. It's not really calculus right there, okay? This is common sense stuff. They don't teach as much of this in the low levels anymore because Common Core has destroyed everything. But anyway, this problem is filthy. It really is, okay? And do the best you can with the homework. As far as what your homework is, I don't know. I have to take a look. Let me see here. Okay, so your homework, cool, integrate the rate problem. It's going to be a calculator one. There's going to be some cool stuff in there. You know, make sure you try that problem. It's not too terrible. I think that one's actually pretty doable. There is one thing in part D that we spoke about on the recent part ones that we did, so I hope you did them. And then there's going to be a physics problem that has two particles like this one, but it won't have one actually that's a trig function. One of them is actually going to have an ln, so you have to, play with that. And it doesn't have the distance between them thing, but we'll get to that at some point in time. You know, a little tricky, okay, that second one, so do the best you can with it. Remember, it's about earning points. All right, sorry, this is a long video, but we got Scooby-Doo, we got work to do. So work before the AP exam, the week before the AP exam. This is Tuesday. Yesterday was Star Wars Day, but I'm making this video on Star Wars Day. I'm all messed up. I don't know what's going on. Anyway, we'll see you tomorrow for Wednesday. Do some more miscellaneous stuff. Thursday and Friday, I'll try to predict more of what you get to see on the AP, judging by what they gave out in AP Classroom. Now, Monday, a little bit of fine-tuning. Tuesday, you got your AP exam. Over the weekend, we'll get you some practice problems. Anyway, love you all. Hope you're doing well. And this is Berto signing off.